A modular automation framework is a popular approach in test automation that emphasizes building reusable, independent modules or functions to create a flexible, scalable, and maintainable testing structure. This framework is highly effective for automating tests in a way that is easy to manage, especially as the complexity of the application under test grows. Key concepts of a modular automation framework. Modularity. The primary concept of this framework is breaking down the test scripts into small, independent modules. Each module represents a specific part of the application, such as login, navigation, or form submission. These modules can then be reused across multiple test cases. Reusability. Modules are created to be reusable components. For example, a login module can be reused in any test case that requires user authentication, reducing redundancy and simplifying maintenance. Separation of test logic. The framework separates the test data, test scripts, and configuration settings. This separation ensures that changes in one area, such as the test data, do not impact the test scripts themselves. Scalability. Since the test scripts are composed of smaller, reusable modules, the framework can be easily scaled to accommodate new test cases by reusing existing modules or adding new ones. Maintainability. Modular frameworks are easy to maintain because changes in the application under test often affect only a few modules rather than the entire test suite. This reduces the effort required to update tests when the application changes. Abstraction. By abstracting complex functionalities into modules, the framework allows non-technical team members to use predefined functions without understanding the underlying code, enhancing collaboration between testers and developers. Components of a modular automation framework. Test scripts. Scripts that define the actual test cases using the reusable modules. Modules/functions. Reusable code blocks that perform specific actions like navigating a page, clicking buttons, or verifying outputs. Test data. External data files, example CSV, Excel, JSON, that contain the input values and expected results used in the test scripts. Configuration files. Settings files that define test environment parameters, such as URLs, credentials, or browser configurations. Logging and reporting. Components that capture test execution results and provide logs and reports for analysis. Exception handling. Error handling modules that deal with unexpected behaviors, enhancing the robustness of the tests. Benefits of modular automation framework. Reduced redundancy. Common actions are only scripted once and reused, minimizing code duplication. Ease of maintenance. Modifications to the application typically require updates to only a few modules, not the entire suite. Better collaboration. Since the framework is modular, team members with different skill levels can contribute by creating or using existing modules. Improved scalability. Easily extendable by adding new modules or combining existing ones to create more complex test cases. Challenges. Initial setup time. Creating a modular framework requires careful planning and a significant initial investment in building reusable modules. Complexity management. As the number of modules grows, managing and organizing them can become challenging without proper documentation and structure. Dependency issues. Poorly designed modules can create dependencies that affect multiple test cases when a change is made. Example workflow of a modular automation framework. Identify reusable actions. Break down the application into distinct actions that can be modularized. Example login, search, checkout. Develop modules. Write independent modules for each identified action using programming languages like Python, Java, or JavaScript. Create test cases. Combine the modules to create end-to-end test scripts. Data integration. Integrate external test data with the test scripts to allow for easy test case adjustments without modifying the code. Execute and report. Run the test cases, collect results, and generate reports. Popular tools supporting modular frameworks. Selenium, with Java, Python for web-based automation. Appium, for mobile automation. Cypress, for JavaScript-based automation of modern web applications. TestNG/JUnit, for managing test execution and reporting in Java. Robot Framework, built-in modularity support with keyword-driven testing. A modular automation framework is ideal for projects where maintainability, scalability, and ease of updates are critical. It allows teams to work more efficiently, quickly adapting to changes in the application under test while reducing the overall maintenance burden.